Hello students, I want to help you answer the questions, or I want to clarify some points based on the assignment that you were busy doing last week. The assignment that I gave you was a bit of a challenge because it's the one where we provide the beams and the columns like viewing from the top. Most of the question papers that you are used to seeing are those that are from the front or side view, especially the front view. So the one that they gave you was the top view. If you read nicely, diagram sheet attached shows a plan view on a steel floor. It's a floor. Okay, that means that everything will be viewed in different perspective. So this is not in front. This is the top view of the floor. Yeah, it's the floor, steel floor section. So this question, they asked you to do detailing of beam 1, which is this beam. Remember that you are viewing from the top. Beam 1 is attached to the column, or is connected to the column, the main column here with the beam coming and there. And then once you look at the way the beam is set, you have to know now what type of connection will be here. We are connecting the beam straight into the rib. This is your rib, and these are the two flanges of your column. So the way the beam is sitting, this face you are looking at now is the flange of the beam. Okay, when you go to look on that side, from this side, you see the eye section of the beam. The rib of the beam is this center line. Okay, that's the web. The web is the here in the center. These are the flanges. This is a flange. Okay, end of flange to the end of the flange. So what I'm trying to say is something that looks like that. Let's say this is your beam. That's beam 1, looking from the front, not from the top. That's why I was saying that when you look at the beam from that side, or from here, looking towards this way, towards the column web, you will see the eye section of the beam. So that is the one that will look like this eye beam here. Here there's a beam which can be beam 1 now that we are going to draw, and there's another beam coming on the right hand side of beam 1, okay, which is this beam here, this beam here, beam 3. Beam number 3 is coming into beam number 1, and it's not going to sit on the flange. This beam 3 will go and connect straight into the web, okay, because the face, we are saying that this center line is the web and the flange is the top. So it's standing the same way you see this one here, except that we won't have this side here, but we'll have this I beam. But when they want a detail of the beam, we need to show the length. So we are not going to draw like this. We need to now project from these corners going up, or coming down. But we are looking from the top view. From the top, what do we see? We won't need the detail of this beam 3. Beam 3 is the connecting beam, and then beam 1 is the main beam. So you need to draw the beam 1 with its length, which is the length of beam 1 will be this length which is given here, all the way from this here, from the center. Remember, this is from the center of the web. So don't say that that's the end of the beam. It's from the center of the column. It's center column. Ne? So you need to take out the thickness of the web for the column, and then from there you need to leave space for the plate, for the end plate, because the beam will come with an end plate already welded with it. So you need to have the end plate thickness of 10, and then you need to know what's the thickness of this web for column C1. Then you remove half of that thickness, then you remove 10, then you are going to do the same on the other side. You remove half of the thickness of the web for the column C1, and then remove the plates, which is the end plate thickness of 10, and then what we are going to remain with is the length of the beam. That is what they will cut. Okay, so we need to know what is beam 1. Then coming to this other connection here, I've already mentioned that beam 3 is coming into beam 1, where you need to notch beam 3. We don't notch beam 1 because beam 1 is the main beam. we notch the connecting beam. So beam 3 will be notched only if they asked us to do detail of beam 3. We are going to notch here, and also it will be notched here. So what I'm trying to explain is that there is beam 3. When we come to do beam 3, it will look similar to that, but the length, obviously, the depth will be the one given in the question. So this will be your beam 3, notched on this side and on the other side. The purpose of notching is that the flange for beam 3 and the flange for beam 1, we are going to be in alignment. So we are going to notch here. And when we go to the notching tables, we have to only focus on beam 3. It will be notched so that it can come inside to be welded to the web of the other beam. Okay, but in this case, it's not a beam to beam. Only if we are talking about this point here. I'm emphasizing about this point here. Okay, that this beam will go into the web of the beam. Okay, then when we come to beam 1 is going into the web of the column. So at this point, don't notch beam 1, we will just do notching of beam 3 when we come to answer beam 3. On beam 1, I only expect you to show me the whole position in the web here, where this beam 3 will be connected to, which means that we are going to do something like that. For beam 1, but looking from the top view, it's going to be hidden details. Why everything will be hidden details? Because of the flange. This flange for beam 1 is hiding everything. When you're looking from the top view here, you won't see these holes here, the holes that are cutting through the web of beam 1. They will be in hidden details. Even you use a plate here, or you use the angle cleat. They are using the angle cleat, so it means the angle cleat will be hidden details as well. If you decide to use the plate, this thickness from here to here is going to be 10 plates that will be welded on the flange on the web of beam number 3. But we don't need the detail of the plate. This detail of the plate or angle cleat will be together with the beam 3 when we come to do detailing of beam 3. So because we are doing detailing of beam 1, here we're just going to show the whole positioning in the web of beam 1, okay, at that point here. But at that point, you will need to show the detail of the end plate, because this beam 1 will come already welded with an end plate here with the whole positions to be, bolted to the web on the column. And here you need to do detail of the end plate. So you're going to have 1, 2 end plate details, and here only the whole positions in the web of the beam 1 only. And these whole positions that will be here will be based on the whole position that this beam 3 will come with on its end plate or on its angle cleat. That's how you're going to locate the whole positions in the beam 1 based on the end cleat or end plate that you are going to use. Alright, so let's look at now what is the size of beam 1. To do beam 1, it's a universal beam 305 by 165. I'll go to AutoCAD and then I'm gonna load beam 1, which is also beam. I'm gonna also load beam 3 because we are going to do detail of beam 1 and beam 3. In the next video, I'm going to do the second question, which is the column detailing. Okay, so today we'll do beam 1 and beam 3, meaning that I'm going to load beam 1 and beam 3. But looking at beam 3, it's also connected to other beams like beam 5, beam 5. So what is this beam 5? You need to also know it's the parallel, IPE flange 160. We're going to go to that table or just open this drawing. It's already drawn for you. And then that is number 5. So I'm going to take this one, IPE 160, and then beam 3 and beam 5. This is the same beam and beam. When I come to do detailing of beam 3, I've already mentioned that you are going to do what? You are going to do the notching here and at the bottom. Notching here for beam 3 and notching here at the bottom for us to have something like this. You see, you can either notch one side or you can also notch the other side. But we are going to only notch one side. I'm sure beam 3, unless beam 3 is bigger than this beam. But you can notch one side, and then we'll follow everything there. Then coming to beam 3, you also have to know the detail here you are going to do the hole positions here. At this point, I don't need the end plate. I don't need anything here because beam 5 is the one that is a connecting beam. Beam 3 is the main connecting beam. This is a connecting beam coming into beam 3. So here we only need the hole positions at beam 3 at this point. But for you to know the hole positions here, you need to know this beam size, because all the hole position that will be here on beam 3 will be based on the size of beam 5. Okay, you are going to get the gauge distance according to beam 5, which will also the same here because it's beam 5, beam 5, beam 5. So if the distance of the whatever pitch or gauge here from here to here is maybe 70 or 80, you will use throughout. Same here, because 1, 2, 3, 4, 5 beams are the same sizes. But my point is we are not going to show the detail of the end plate, nothing, and there nothing. Here you will do notching and then you will show the end plate detail for beam 3. But for beam 1, we are not going to show the end plate detail. We show only the position of the holes and the end plate shown here and there. Now we come to beam 3 detailing. It will have the end plate detail here and here, and only the hole position for this beam coming into this beam, just the hole position. Unless the question was draw beam 5. If to draw beam 5 will come with the end plate welded here and welded there. That is when you are going to have what? To have the end plate detailing. So beam 3 will have here, because it will go with the end plate into beam 1. Beam 1 will go with the end plate into the columns. You know, it works like that. So I'm going to AutoCAD now and then open beam 3, 305 by 165. This is your AutoCAD. Make sure you first open your template, SSD. So you go to File, New. I'm going to be working desktop. Mine is under desktop files, and then templates, then I change here to template, and then we need SSD. All right, anyway, I've drawn some other things here, it's okay. Then I need to open 305 by 165. You go here, File, Open or New. You go back again, not in template, but you go to Symbols. Okay, so you are going to desktop files and symbols, SSD symbols. We are looking for I sections, parallel flanges. It's this one, and then change to drawing. Okay, this one looks empty. Drawing DWG, yeah, that one, drawing DWG. It's 135. What was that? Let's just go and check again. Or 305 by 165. So that's the one you must look for. 305 by 165 by, what's the weight? Very important, by 41. Okay, by 41 is this one. Open. This is the main beam, which is the beam 1. Then I need also beam number 3, and then what is beam 3? 203, it's smaller, 203 by 133, beam 3, 203 by 133. Okay, 203 by 133. File, New, 203 by 133. Then what is the mass? 30 kg. Okay, 203 by 133 by 30. This one. Open. This beam is what I need, beam 3. So you can just copy this beam to clipboard. Beam 3 must go into the main drawing. This is our main drawing. Paste, I'll put beam 3 here. Then I need to open beam 1. This was our beam 1, I'm sure. Copy, paste. Yeah, that's the main beam, beam 1. Then we need the last beam. According to the sketch here, when you do detailing of beam 3, you need beam 5. When you do beam 1, you only need beam 3. Okay, you can also take the column. We will take the column because obviously we need to know at what point they are meeting. We need to know the center for the column. All right, so I'll bring the column in as well. So beam 5 is IPE 160. IPE 160. File, new. You go back to SSD symbols, SSD, IPE taper. So beam 1, let's quickly do beam 1. When I come to beam 3, I will look for the size of beam 5. I really need to find it. Okay, so beam 1, I've already brought it. So what we do is, what's the length of beam 1? From the center of the column is 1250, 1250, 1250, and 1250. Let me bring the column again. We need to bring the H column. This H universal column is 305 by 305. We need it. Universal column, so it's fine. I'll go back and just now take universal column, H section columns, H sections columns. Okay, parallel. It was 305 by 305 by 97. 305 by this one by 97. Open. Okay, then copy. We're going to take it to the main drawing here. Paste. This column I'm going to rotate. Okay, according to the question, it was given rotated like that. Yeah, it's sitting no like this. Does it sit? It's sitting like that. Okay, so I'll draw a center line through this column. Okay, then this center line, I'm going to offset it by that distance. So what I've done is I've drawn this center from here on this column. 1250, again 1250. You go to offset 1250, enter. Again 1250, enter. Okay, so let me just move them down. Yeah, I'll move here. All right, and then the beam that we are talking about is sitting here. This is beam, our beam 1. I'll rotate also this beam 1. I'll just move it. Not rotate, you have to move it near the column. It's coming that way into the column. Okay, but I don't need the detail of this beam. We have to do it from the top view. This column is from the top, this is from the front. So if you want to do from the top view, you only see, you know, here. Let's switch on that. Yeah, then copy. This is from the top. Okay, we are looking on the top here, so I will just move it on the side. Let's say somewhere here. We are looking from the top. Then I'm going to mirror this column that is on the other end, and I'll mirror it here. Okay, you see, so the beam is coming in the center. We need to make sure it's centered. Let me move midpoint. There's a midpoint for the column. Yeah, it's sitting like that, but we don't need it inside here. You can just take it out. It's just a guide. Okay, you move it. This is what you see from the front, not that it's the top view. The top view of the I-beam, you will just see the flange. Let me just put it this way. We are looking at the top here, going deep inside. These are the edges, and this is what I've just done, projecting. Okay, so you can now trim. I'm going to just trim. I'll trim until, you know, the face of the column here. Okay, that's where the beam will sit, but also we need to put, delete. Then we need the thickness. We need to put the end plate here. I'll come and put the end plate. Let me change this to outer line so that we see what's happening. Then you trim the beam here. Guys, we are looking from the top view. You should not get confused when they bring a question like that. This is the top view of the column, top view of the I-beam. So with the I-beam, we need to see the flange, but it will be in hidden details. Okay, the web will be in hidden detail. The flange we have already put. These webs you can draw from here and copy. Yeah, this will be in hidden details. Also, you trim. You can trim here. Repeat trim. You come trim to the other side. Here and there. And then you can just delete this. This is the hidden detail line. So when I scale down, you will come and see the dashed lines. Okay. That is the web in hidden details. This is the column center. I wonder where the column has gone. It's mirror, because there is another column there for formality, but I will later on remove the column. Yeah. Then we are saying we are doing detailing of the beam. Okay, so what you are going to do, for you to get the whole position for the beam, you have to know what is happening. This beam, if I rotate, okay, just for you to see nicely, let me try to rotate it that way. Yeah, this is the beam and this is the column. Okay, so when we are looking from the top view, we are going to see how it comes in here, but the detailing won't be seen. Why? Because of this flange. From this green line to the green line is the surface of the flange, okay, which is this flange here. That is the surface. So we need to know now at what position are we going to center the holes when we put the end plate. The end plate will come around this beam here, okay, around that beam here. That's how you will see the end plate. So you can now draw the end plate, but we remember that we always have to go outside by 10, okay. So whatever this is, let me measure this. The beam is 165.1 plus 20, you can say plus 20, 10, 10 for the welding, okay, for the plate, 10, 10 out. So I'm going to draw. If you want, you can come here, just draw a small line. You say 10, enter. Then you come here, you draw another line, 10, and you draw another line out, 10. Here you go out by 10. What am I doing? From this edge you need to go out by 10, from that edge by 10. So when we draw the end plate, it must be here and also, yeah, there. That's why I said 10, 10. So you must confirm that is 10. If it's not touching on 10, you can extend. Okay. You can bring it down, but please make sure that it's in line with that one. Yeah. So let's say, I think it didn't touch nicely. You come here, then this corner is 10, out with that corner of 10. Yeah, they meet here, correct. Then you can now delete those. This is the end plate. You can delete that and delete that. The end plate, but we don't need details there, you know, we'll come and do the end plate later on. For now, it will sit like that, and then you offset. You need to draw a center line, looking at the end plate. This is the center line. The size of this beam, you need to go to the blue book and get the gauge distance. The gauge distance is the position of the hose from center going that way and that way. So this beam 1 was 30, Yeah, 305 by 165 by 41. And the question paper with 165 because they said that beam 1 is 165. Okay, this one is what we use, not the first one. This is the depth. We use 165. When I'm in the blue book here, I must look for 165, which falls between here 165 and 191. So we are using 90 gauge because that is the 1B is 165. So half of 90 is 45. You come here and then offset your center line 45. Okay, you go to offset 45, enter this way and that way, so that we have a gauge distance of from here to there of 90. Okay, that is what we are trying to do. Then to get the pitch, they said only 4 holes must be here. Pitch, recommended pitch for all the bolt holes of 20 diameter. You'll see that in the blue book there is a table that talks about recommended edge distance. The edge distance recommended, okay, from the edge. If you are using diameter of 20 fasteners, which are the bolts, your edge distance will be 40 from the edge of the plate, end plate. Your minimum is 40, okay? And then you can work pitch, which is from bolt hole to another bolt hole, is 70. So we work with a 70 recommended distance because we are working with the 5, enter, here and here. So you can have a hole here and a hole here. When I offset again and again, but they need only 4. So when I draw a diameter hole here where the pitch matches with the gauge, they're supposed to have 22 for the threads. Okay, this one here, not diameter, radius, diameter. If you want diameter, you come here, choose center diameter, then you type 22, enter, copy to the other end. If we had holes here, we would have put like that, you know, because it's 70, 70, 70, 70. It's 35 we did, ne? Yeah. One here, then you remove this one and remove that one. Then we would have had one here again. But because they need only 4, we don't need to show this one here. The recommended pitch is the distance from here to there. Can you see? 70. Also from here you can repeat to here is 70, but they need 4 bolt holes, so I'm going to remove this one. Okay, but in real life there are holes here, and then we remove those lines and then we leave that one with a gauge of 90. Okay, then we are going to project with this detail. We are going to show and then project to show the thickness here on the end plate. I want to show the thickness of this end plate. Okay, the size of your end plate will depend on the depth of the I-beam. So this will be our size here, somewhere there. Okay, and that will be the width, but it's got a thickness of 10. And make sure that when you do dimensions, they must be under dimension layer. Don't just dimension on center layer, dimension layer. But we need to scale down the drawing and then we do dimensions. I want us to now come and show the thickness of the end plate here. You first project the end plate. Okay, you draw a line, that is the end plate. Then you can copy from here, where's the end? Yeah, to here. The end plate is 10 millimeter thick from this end here. So I'll draw that line here from the column here to here, that red line. Then you offset 10, enter. You offset 10 inside. That's where the beam will end. Then you can cut off the beam now, trim further. That will be the original length of your beam. And then trim the end plate, trim the end plate here, and trim here. And it's easier to work with end plates than to work with angle cleats, unless the examiner wants you to work with angle cleats. Okay, and then you can put this on construction layer. Yes, this you trim. The web of the beam will end only on the end plate. So this is the green part. The beam will have a line here to here, and this line for the beam is outer line. Then you can mirror this end plate to the other side, because it's the same mirror in the center here to there, enter, and then you trim the beam. Yeah, now we can project the hole positions here now on the thickness. I'll come and remove this column. It's just guiding us, okay, for you to understand. We're looking from the top, and if we're looking from the top, this will be in hidden details. Don't forget, this piece will be in hidden details. Yeah, because you're looking at the top of the beam. When I go to the drawing here, what I'm saying is the flange is covering, you know, the flange is on top, and then you have a small thickness there, but you are going to show it. You will show the only one that will be hidden is this web. So we'll leave the rest will be visible, because you're looking from the top. You will see that connection here. I am now going to project the holes. RE, enter. Okay, when you see the circles like this, type RE, enter. Escape, RE, enter. Yeah, and then you draw your construction line and the center line also. There is the center line. Copy to here, and then that's the circle, both holes here and there. Okay, that's where the position of the holes will be seen. You trim now only in the thickness, even in the column, but that will be part of the column detail. If you need, you can leave them for the column. Okay, you trim. Even in the column there will be holes, so I'll try to leave them for now. What, I forgot one here. Center line. There's the center line. Okay, and then trim. Okay, the center line needs to come out a bit, and then the holes will be in hidden details. That's what I meant, because you won't see the hole position, so the holes must be under hidden details. You select and you come here, change to hidden details. When you scale down, you will be able to see the hidden details. Then I'll also just mirror all this to the other end. Mirror on the center here to the enter. Yeah, that is happening also that side. And then we need to show the detail here. Later on, we are going to dimension. Delete that. Delete. Can copy the center line. You need to always have center lines on there here, but must be trimmed somewhere here. Don't go out. I wonder where the circle has gone. Copy. Okay, dimensions I'll remove for now. We'll come and dimension later. We don't need this center anymore. Okay, there's the time you come and remove this now. We don't need this anymore. You can remove or copy it somewhere. If they ask for the column detail, you might need this whole position on the column. So what I'll do, I'll just copy. I'm not sure if they asked the question on whole column detail. I'll copy and then I'll delete later. So this one, when you copy, just put it aside. You know, you come and use it when they ask for the columns, and then you can come and delete the column and delete the column. Okay, the column center you need to show. Once you delete the hole, you can now trim unto the thickness of the end plate. That one I was just showing you that the same holes are in the column. You just trim until there, the same way you do here. Trim, 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 trim. All right, and then we can do the things here. Let's check now in the question paper what happened there. It's happening down here. Remember, I've just rotated the beam, so at the bottom of the beam I need to do this. I rotated clockwise. Okay, so this will be at the bottom. If you rotate even counterclockwise or whatever, but make sure that you position now the bolt holes according to beam 3, of which we said that beam 3 is 203 by 133, which we have brought. Beam 3 is coming, where's beam 3? Yeah, there. You can just move it nearby here, and this beam 3 is coming into the other beam. Okay, so what you are going to do with the beam, being that it's coming, you need to show the webs. If we rotate it this way, we are looking at the top. Okay, if we look at the top view, it means that, yeah, it was the fine like that. It will be like this. Yeah, it's fine like this. It's going straight there. The beam will be going straight there, and then you are going to do the notching at the end when it reaches there. All right, so it's fine like this with the web here. So what you do, you are going to center it with a center line, maybe here. Okay, if it's sitting like that, we are going to see the webs from the front only, not from the top, from the front. So here it's the top view. So when we're looking at it from the top view, you are only going to see the top of the flange here. So you can now try to project, which is not necessary. What I only need is to show the hole position on the beam here. Yeah, the hole position will be, you offset the gauge distance using this center line. But what is the gauge distance for this beam? We are saying the beam is 203 by 133 by 30. 203, you go to your blue book, 203 by 203, this one, 133. 133, this is the depth. This is the mistake you should not make. Do not use these to gauge, to get the gauge distances. It's a big error. You must always use the breadth. So the breadth for beam 3 is not 203. Okay, I pardon there. The beam 3 has 133 breadth. So meaning that when we come here, don't look at this one. Don't look at 133, 203. You must look at 133. 133 is between 120 and 146. It's in between here. So we work with 70, 35 and 35. All right. When you come here, 35, you offset 35, enter here and there. These will be the centers for the bolt holes. Okay, the hole position. Remember, this beam will go into the web here. Will be into the web, not on here. No, it will go into the web, and that piece will be hidden because the beam apparently will come with its own end plate here. Okay, when it's coming, though we don't need to show that part of the beam, it will be part of beam 3. The beam 3 will have its own end plate, which means that it will be going here. Let's say that's the thickness of the plate, and then you trim. You go to trim. The plate will be trimmed somewhere here, here, here. You see the way I'm trimming? There, there. That will be the end plate that will come with beam 3 to be welded now on the web of on the web of beam 1. That's where I projected from the plate. Okay, with a 10 thickness. So now if the beam now is going to be trimmed, it will be trimmed somewhere here. That's the beam. No, that's not the beam, that's the center line. Well, those are the center lines for gauge distance. Okay, the beam is this one. If you want to see the size of the beam, come here and then project here from the beam. Copy, These holes are for the gauge distances, so we can trim them so long, and when we trim them here. They need to go through the web as well. Yeah, it's fine. I'll delete that. These holes are not only on the plate, they are also on the center line. And because the hole position is 22, just offset these ones by what? 20 is for beam 3. Then we work with the center line somewhere there. Okay, it will be a center line, and offset, because the pitch is 70, offset 35, enter here and there. If there's need to offset later, again, let me say we'll leave it there, and then you draw a circle here of 11 radius. I hope this is 11. No, it's still on diameter. So it's still on diameter. You just type 22, enter. Yes, and then you can match properties. These center lines, we don't need this one. Then you can copy to here, to there, to there, and these holes you can project, or else you can just come here and offset 11, 11. You come here and say offset 11, enter. You offset to the here, 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 and then trim. These are the hidden details. These are the holes, and then you can change them to hidden details. Hidden details. All right, so like I said, everything will be hidden. Even the plate will be hidden details, because we are not seeing it's under there, okay, because of this flange. So all these will be hidden details. You can now delete this. You need to leave that center line, delete that. This is your beam. You need to trim the beam, which ends only here and there. And this beam, I don't need it, but what we're saying is, to answer the next question, you will just copy this, copy that, copy to come and answer beam 3. Move it away like that, and then when you move it away, you don't need this anymore. Delete. That is part of beam 3. The end plate here is part of beam 3. Okay, and then I think we need now to do beam 3, and then to do detailing of beam 3. This is the top view, because we said the beam is going to be notched, being that it's going into the web of beam 1 here. We need to notch the beam here. We are not going to show the notch from the top view, so this beam 3 will show the detailing from the side view. We'll be looking from here where we see the flange and the bottom flange. Okay, so to show the notch, you need to have something like you need to have 2 beams coming in like this. This will be our beam 1, and then beam 3 will be coming from the right hand side, not from the top. So we are viewing from the front. So we'll see the web with the beam. The thickness of the web is here. We'll see the flanges and at the bottom, and then we'll show the notch of beam 3 coming into beam 1. We have already done the detail of beam 1, and we are showing the holes on the web of beam 1. So that is what we are supposed to do. So this beam 3, I'm going to move the end plates. The end plate won't be going all the way that side. It needs to be notched. Okay, so we are going to notch the beam. This is the center of the other beam, which is beam 1. This was beam 1. If I bring beam 1 in, my beam 1 was this one. I'll copy it here, and then we rotate it in place without the holes. Okay, I'll bring beam 1 here, and then rotate beam 1 to sit that way. It's not necessary to show the plate for beam 1 and the end plate. That is where beam 3 is coming in. I'm going to move this end plate for beam 3 and move beam 1 to align with the top of the flange here. Okay, and then that's my beam 1. And then I'll rotate this view because we are looking from the side view. We won't see, we'll see something like that. Rotate the entire of this end plate for beam 3, which will also change in shape. So it will be like this. And being that we are looking from the front, we are going to show the thickness of the webs. Okay, that's the top of the beam here. I'll put it here, and then you can now draw the webs. Just project from here, copy this one here, and there's already a member down here. This is beam 1. I want beam 3. Beam 3. Let's try to rotate this one and then move it, this member to be, yeah, it's this one. So this one is not sitting right. This was our beam 3. Okay, and then it must be on top, so I'll move it to be in line with, let me move it closer to be in line with that one. Yeah, the top of the beam is here. Yeah, we want something like that. That is beam 3 from the top, from the front I mean. Then you're going to move this one here, and then you can copy that one, because now we are on the front where we see the depth. From the top we saw the width. Okay, from the top that was the width we showed. That's why we turned it the other way. So from the front this is the right way, and yeah, you're going to extend this. That's where the beam is ending. Then extend your lines to meet with the beam here, and then you can now trim that part and trim this part here. And then trim and trim. This will be out. Alright, so the thickness of this plate we are going to change. Also the position of the hose will change. We are now working from the front view. So extend. Okay, and the web also must be not here. The web is now this one. Why we were seeing the web, it was because it was from the top view, but from the front we'll see like this. Okay, and then once you show the front, you are going to show the hose here on the web, the position of the hose according to the other beam which I'm going to bring in. This side here, it's at this point where it is now connecting to, not this one, assignment here, beam 3. It's those points here where we have IPE 160 beam, those points. So we'll come to that point. Let's finish the notching part. With the notching part, you need to know that this beam here is coming in here, so you can now move this away. The end plate detail, you can move it somewhere this side, and then try to bring this beam near. Okay, there must be a small clearance there before you notch of like 2 to 3, so you can offset 2 to 5 they say. If I use 2, that's the clearance, and then move the beam, which is the main beam, to that point. Okay, and then we have to now notch this beam. We have to notch beam 3. How do we know what point to notch beam 3? Because beam 3 needs to come and sit here. Okay, it needs to come and sit on the web according to what we did on beam 1. Beam 3 was coming inside here. we have done the detail of that part. Okay. The beam 1 was ending with the columns here. That was on the column. But when we look at beam 3, I've already mentioned that it's touching here on the web. So you need to have a notch, but the notch you can't show on the top view. So if we are looking from this side of the beam, from this other side of the beam, okay, or you can look from that side of the beam. So once you are looking from that side, you will see the plate here, and the plate here, and the plate here with the holes. In fact, we'll just show the holes on the flange. Okay. All right, so now notching of this beam. What is the size of beam 3? You go to the question paper. Beam 3 is 203 by 133 by 30. To get the dimensions of the notch, you go to the blue book. Okay, 203 by 133 by 30. This is the beam. Okay, 203. Was it 303? 305. I'm forgetting. 203 here. 203 by 133. So when we are here, we look at 203 by 133 by 5. You need to know the clearance is 5. Okay, we are working with 5, and then there is 74 length, and H2 is 20. So you are going to offset 74 and 20 down. What is length? The length, you have to leave 5 clearance here. Okay, I will leave 5 clearance, and then from there I move the beam in there. Then from there I'm going to offset 74, and then from there we offset 20 down. Okay, so when we go to AutoCAD, you are going to have a line here. Let me copy this one. Copy, you put it here, then offset 5, enter. That will be your clearance for the beam. That's where the beam will come and end. And then offset this one 20 down, enter, 20 down, and offset this one 74. Yeah, 74. So it's on the center here, 74. Let me delete that. Then you can now trim. So what are you trimming? You are trimming this piece away, and the notch is coming unto here. So this must be trimmed, and this must be trimmed. Okay, then they say there must be a fillet. What is the fillet radius for this beam? Fillet radius, that is R. Okay, R is 10 minimum. So you can work with 10 minimum, and then we go and try to put the fillet. 10, enter. It's here and here. Okay, undo. You need to trim this piece here. Yeah, then try to do a fillet of 10. Radius, enter. 10. Why it's not accepting? Fillet, R, enter. 10, enter. Okay, it will be here and there. That is the radius of 10. Then you're going to move your beam, the entire beam. Not even the beam. Let me move the column. I'll move beam 1. Okay, they'll meet here, so that you leave that allowance there. So this one we can delete. So what I've done, you can do to the other side, meaning that this one you just mirror. Okay, mirror halfway on the beam. Enter. This we don't need that. Delete. Then you can come and trim that one and trim that one. We don't need the column. Okay, match properties. The column was just, the beam was just showing us, you know, helping us to do the connection. This is a beam to beam, so the main beam is this beam 1, and there's no need of stressing to get to have the beam here. Okay, so you do that, and the details on the end plate will be shown here. Those are the details that are on the web here. So you can just leave the end plate here, and then here you leave the end plate there. On the beam here, there's going to be holes here, and then you're going to have that. What we are going to have is something looking like this is structural book, but the notch is something like that. Okay, when I zoom in here, you'll see that that's where the beam will be attached to this piece here, and that's where the plate is. So once you leave that thickness of 5, then you can do the notch, and once you put the notch, you put the thickness of the plate. So I want to show you the final drawing, a detailed drawing that has a plate in. So what we are showed there is the plate. You see, once we notch, we need to put 10mm plate here. You leave the allowance, then 10mm plate. In this situation, you are still going to offset 10. So I'll copy this, not offset, I'll copy, because you still have to show the thickness of the, then we set 10, enter, offset 10, enter. The plate of 10 will start here. That is the thickness of the plate. So you can move the beam. Okay. Then you say move. Then you can come and show the end plate thickness. The beam will start here. Then here I'm going to bring the thickness of the end plate, of which you can draw if it's 10. You're going to say offset 10, enter. Yeah, then there's a 5 left here, which is your clearance. This is sitting here, our notch. Move this piece to come and close here, and then close that there. Alright, so we need a line here for the plate, and then for the whole position of the plate, this is the plate that we're going to have. You can either project from here, okay, but the plate won't go that far. The plate will start, I'm going to move this plate here. Move the plate so that the top of the plate can be in line with that one, or even a bit lower. You can go a bit lower to leave for welding, 10mm lower. I'll put it here, and then I'll move it down by 10. Hey, the holes are left. Undo, undo. Move. We want the plate to align with this top, okay, but the beam is not here. Remember that your beam is in line up here. Okay, so once you put the plate there, you have to work with the pitch. From here you can offset or use the center of the plate, and this plate is too big. Make sure that it just can go all the way up to here, or even less. Okay, you offset 10 down here. That's how we do it. So I'm going to have to draw a line here. Okay, for welding you can go 10 down. If it's 10 down, then I can bring this one here, okay, and 10 down from the edge there. It's fine. You can set 10 down, enter, and then you can move this to align with that 10. Okay, something like that. You can have a plate like that. Then we are going to offset pitch. Remember the pitch we worked with from the center here. So you can work with the pitch on the middle here, this line, and offset 70, but I'll offset 35, and then 35 here. You can have the hole there. If it's 35 here, no, that will be too much, and then that's where you move your holes from the center here to there. Move these holes to here, and then those are center lines. You make sure that you match properties here to these centers. You can delete this one and then change this plate to construction line. Delete that, delete that. So if you want to save money, what we usually do is this one won't even go up until there. You can go inside by 10. Okay, the same way this one was sitting, you can come down by 10 and by 10, and then you weld it there. And then once you weld, you're going to move everything here, the center to the center here. Then you save money than you welding everything up until the bottom. Okay, so there must be some sort of allowance left. The edge distance you can work with 40 or 35 for this one. So let me see how much is here. So let's say offset 35, enter. If I offset this one by 35, it's up until there. So I'm sure this one is fine because that is the minimum. How much is this? 45. Yeah, 45 is better, which you also have to leave here. It will be 45. And then you show your center lines here, and then match properties, then copy from the center to the center there, undo. You need to copy the center lines from here to there. And then once you do this, we are going to scale it down and put the dimensions in. Okay, please make sure that the plate is closed here and the beam is ending on here. This is the 10mm thick plate, which is this one here. We do the same on the other side. I'll just delete this. Whatever is happening here must be happening that side. So mirror and mirror on the center of the beam there. Yeah. And then you can extend. This one is wrong. Then extend this line here. Okay, so if we want to locate now the centers on which we have the other beam coming on this section, I'm going to use this as my center line. So let me move it in the center. Yeah, there. Then offset 750. That is in the question paper. Okay, and 750. Then offset 500. So we need to readjust this beam. So 750, then 500. Okay, after 500, let's look at the question. Look here, that's beam 3 from the center, 750, then 500, 500 into the center of the other beam. So we need to readjust. The center of the beam is here, meaning that you have to move the center of the beam from here to there. That's how it is. And then you can trim the notch and delete that line. Yeah. Then this one also, you move the center of this beam 1 into this. That's the center. And then you can now trim. This one is wrong. Okay, there are 2 lines here. Delete 1 line, and then here you also have to trim the beam. Then the thickness of the plate. This is the 5 clearance. Just confirm that it's the clearance of 5, 4.4. Supposed to be 5. Okay, I'll just mirror. Let me delete this side and then mirror this piece. Yeah, we're going to mirror this in the center here. Okay, yeah, that is the end plate, so the beam must end here. Once that has been done, you have put the notch. You need to show the hole position. Remember what's happening here. We are not looking from the top, we are looking on the side view. So we'll see the hole position for this beam that is coming here. The beam that is coming here is this beam 5, okay, beam 5 coming from the top side of beam 3, but we are looking from the side view, so we'll see the beam as it is sitting on the center line here, on the flange. It's sitting on the warp of beam 1. It's here. So what is that? IP beam 5 is IPE 160. So in AutoCAD you have to go File, New, and then you look in the parallel eye sections just at the bottom. You know, when you go to the saver, you will have to go to the symbols, SSD, then you look for eye sections, parallel flanges. Then down here you find IPEs 160, this one, okay, 160, open. This is the I-beam. Then you are going to copy to clipboard, bring here, and then you are going to paste. That is the beam that's coming here. So what we'll do is we need to center it. It needs to be in the center. I'm going to do this center so that it can now sit on the center. Okay, we'll see the beam how as it comes. So I'll copy, and this is the center that must be here. Then you copy all of them onto the other parts. There's another one here, another one here. There's no need of showing the entire beam. We just need to show the holes here for this beam. So this beam IP 160, you need to know what is the web, the breadth of this flange here. It's 86. So when we're looking for 86, the gauge distance for 86, you go to your blue book for IPR. Let me say 42, enter. This is 89. That was 86. Yeah, so between 76 and 89, we are using gauge distance of 50, G1 from the center here. So it's 50, 50. So you come back, not 50, 25, 25. It should be 50, G1 from the center. So it's 25, 25. When you go here, you are going to offset 25, enter. There and there, and then offset from here. We are working with the pitch now. This is the center. I'm going to offset 35, recommended pitch 70, so it's half, which is 35. Okay, the recommended pitch is 70 between the holes. So offset 35, enter. From here, let's say there's a hole, you go there, and another one here. Okay, then I can draw a hole of radius 11. Yeah, then copy. There will be 4 holes here, one here, one here, one here, and we're saying the pitch should be 70. You can see that is the pitch. And to gauge distance that you took that side, which is from here to here, that will be the gauge distance for those holes. You can show here to dimension. And once that has been shown, you don't even need to show the I-beams. What you do is now copy the hole positions with the center lines. Copy on the center of each. There, yeah. And once that has been done, then you can just delete this beam. We don't need information now for this beam. We only wanted to know the location of the holes using this beam and looking from the front. From the top, we were not going to see these holes. We were going to see the thickness on the web. I'm not gonna delete this. Yeah. And then this is the line, which is the main center line. You need to extend it a little bit out and then make it trim, you know, short to come and align with that one. Must be very neat and do yeah. Here again, we don't need these I-beams. You can just leave the center to the beam, remove the I-beam and leave the center to the beam. Also, you can try to trim. Okay. And once you trim, you put in the dimensions. You see, from the center of the beam to the center here. Then you go to annotate continuous dimension. Continue to dimension, continue to dimension. We are going to dimension here as well. We need the dimensions of this plate. And then we need the size of the plate that side. We need the pitch. We need the gauge distance. Okay, what else? And then you put the title here. You do the same for this beam here, or else you can just have a copy of the other one. It's fine, it's the same things. The dimension, okay, repeat dimension, pitch, repeat dimension, G1. What else? All right, and then you put the text here. Okay, you come here, but before you text, you need to scale this beam down. This beam 1 also, it's the same situation. Make sure that you dimension it. That was the example for beam 1, and then it was viewed from the top. Okay, it was viewed from the top, so the center here must be in line with the center of this one here. That's where the web is, but must be outside there. Then try to shorten that. And then we put dimensions. The beam dimension is the beam distance from here. We need that distance of the beam. They will cut this length for the beam. Then we need the center to the column. Beam 1 was going into the column web, and the center was from here to there. You need to leave the column centers. Okay, and then you show the distance here. Try to make them neat and short. And then we put the plate size. This plate is looking from the side, remember, not from the top. When we go to the side here, from the right view, looking from that side, you will see this plate, and it's sitting upright. Not the way I've put it, it's sitting upright. From the front view, you'll be able to see the length from here to here. Okay. but this is from the top. We are saying from the top, we are only saying the top here. Then the position of the other beam was here, so you need to move this center into the center of the beam. Yeah, and then you also have to put the dimensions now from the center of the column to the center of the beam, and doesn't look alright. Dimension. Okay, I can dimension from here. To here. Then you can go and rotate continuous dimension, then it goes to the other end there. So you are going to scale down both of these into scale 1 to 10. Select scale 1/10, enter, and then bring the template in. Click here. This is for question 2, and bring this template here for question number 1. Question 1, if you can't see the dashed lines here, this should be hidden details. You can go File, Properties, and try to play around with that 2, enter, again maybe 5, enter. Then I'm able to see the dashed lines, and then I can match properties from here and anywhere else where I can see dashed lines. These are hidden details, but you won't be able to see the hidden details. On this other side, the hidden details are okay. We won't see. There will be holes here which are hidden details, and you need to project center line. Okay, and this should be center line. We'll change, copy to the top here, center there, match properties, center line to center line to center line, and then match properties, hidden detail. I'm gonna match from here, this one to these other ones. This will be hidden details, and then you can trim. Trim there, also on the other side, or else you can just delete, and then we are going to mirror. Okay, I'll delete all of that, and then I'll mirror from this end here. Oh, it was supposed to be trimmed here on the plate only. Okay, these hidden details will be ending on the plate. Center can go over, it's fine. This we trim until there. The center line, please make sure that you try to lengthen it. Even that way is fine. Okay, I'll try to be here and there. Don't go over the other center line. Yeah, leave it like that. And once this is done, you mirror to the other end. Same mirror, using the center line here, midpoint, enter. Okay, and that is the detail there. You can move it near. Next is to type here. You go to text, then you're going to text here. It's fine. You say how 10 millimeter plate width, diameter. You are going to put diameter 22. So at that point you are going to insert a symbol for diameter, degree, for diameter 20, with diameter 22 holes. Okay, one off. This is one plate, one off. Okay, and this one should be under text. Then you can just copy this one here and put here. Then you come down here and do the next test for the title of the beam. The size of the beam, beam 1. Okay, universal beam, UB, and then you check the size of beam 1, 305 by 165 by 41. 305 by 165 by 41 kgs per meter length. One off. This beam is there is only one. If there are two beams, beam 1s, let's check. If there are two, you say 2 beams. There is another beam 1 here, so it's 2 beams of beam 1. Okay, they will cut 2 beams of the same size, so you say 2. You bring here 2 off universal beams. This one should be size 5 millimeters high because it's the main heading. 5, or yeah, it's on that one. Or you can right click, you go to properties and go and change the texts under text size. Yeah, it says 7 or 5 is fine, and then put it under text layer and then move it nicely there in place. You do the same for this other beam, and yeah, if there's anything, these dimensions must go back to original dimensions. We have scaled down and the measurements are wrong. This is not 5, this is 70, this is 50. So what do? You select this. You can first check on annotate and then go to scale 1 to 10 if ever there is one. If there's no scale 1 to 10, you have to go to primary units. Select this, right click, properties, you go to primary units. There's primary units, and change the dim scale, this one, dimension scale. So you select the dimension, you right click the dimension, then you come here to dim scale and change it to 10 because you use scale 1 to 10, and then it comes back to the original. Then for the rest, you have to match property from this one, which is correct. Match property to that one, to that one. All of them you can highlight like this. To this one, this one, this one. This is not allowed. I'm going to clean up here. Okay, this should be 70. Something happened. 70, 70. Okay, dimensions must not be, you need to drag them down, must be very neat like that. Then move this one out away from the 70, make sure it's neat. Then continue matching properties. I see this one here is not changed. Then you can dimension also this one, and then you match your properties. Match properties. This one to that one. Match properties. This one to that one. Where else? You need to also do here. And then match properties. Match properties from here to there. This one is not allowed. You need to clean up. Take this bigger dimension, drag it out somewhere there. Okay, this center line is not needed. You can delete. We have another one here. Yeah, you can just delete. And then if you can't see the centers, you select the line, right click, properties, then you increase the line scale, maybe 5, then press enter. If it's not 10, enter. I see it's still not showing. Try to go back to 1, enter. 0.5, enter. So if you see that it's still not accepting, you need to look for some, let's see, center line. Yeah, for a center line that is, you know, like this one, then you match from here. So you select this center line, match properties to the other ones. Yeah, it's still center, so we need to reduce the dimension, the distance in between. 5 maybe is too much. Enter. Let's see on what scale it is on. Select, right click, properties, try to say 0.5, enter. Yeah, there 0.5 is accepting, so you can now match to 0.5 and that one, and the rest of the centers. Yeah, this one 0.5, which also will be the same to these ones. Okay, and that's how it is to be done, guys. The next session I'm going to explain how you do the match properties. I'm going to explain how you do the columns. I'm going to answer question 2, which was the column question. Yeah, that's the one I'm going to help you next time. Okay. So now what you must do is to print. If the work is finished, you edit here, you double click and put your ID number. Okay, double click, put the date. You know, these things you must do during exam. Otherwise, if we wish to print this, you go to file, you go to print direct here, choose the printer. We usually use Toshiba Staff Room, select, and then you go to window. This monochrome, we are missing the building plots, SSD plot style. If it's missing in the exam, you need to ask the invigilator, or you need to come in on the screen. You right click on the screen, you go to options, you load the plot style. Okay, when you go to options, you go to profiles, then import, and then you go into the saver that will be on your desktop. You open saver, and then when you open saver, mine is not connected, you go to public. Inside public, you will get this drawing, which is your DWG. I think I've put it somewhere. I'm not sure where I put DWG drawing. I do not have it. That's why it's missing plot style. So you get this drawing 1. It's written drawing 1. And then when you bring it, open it, it will come and appear here. Then you say set current. And then once you are done, okay. Yeah, then whenever you try to print, it will show. Then you go to print. Mine is still not showing because I'm not on the server. So choose the printer name, Toshiba Staff Room, window. Okay, you are going to click there, select window, and to the other corner. Then you can preview. Why it's looking in color? Because I'm missing the plot style. You don't have to have it in color. It will be very faint and you might fail the exam. So you need to go back and fix your plot styles. Okay, you make sure you fix your plot style. Once the plot style is done, then you can just click on print. Okay, that's how we do it here. So mine is printing, but unfortunately it's going to be very faint. That's how you print. You say question 1, you put the question number, question 2 here. Question 1 is this one, which was beam 1. Move it here. And then there is question 2. Yeah, question 1 and question 2. Put the title for this one, put the information for this one. In the end, guys, the memo is here, SSD memo. This is question 3. Okay, this is question 3. Question 1, beam 3. There's beam 3. They have worked with 80. It's fine. We worked with 74 according to and we worked with 20 deep here. There are the 2 holes here. There's the beam center. Okay, you can see the 500. One of universal beam. 1, 2, 3, 4. These are the 4 holes. Okay, for that I-beam. Yeah, and they have worked with the pitch. Then which other one? Yeah, this is here, and the pitch is 70. You can also work with those numbers as long the edge is not less than 35. It doesn't matter. So this is all you're supposed to do on the total length. That's how you get the answer for the beam. All right, I'll see you next time, and if there's any questions, please feel free to contact me. Goodbye.